So hey, what's up guys, welcome back to another video, and in this video we're gonna do a Scratch project in which we're gonna make a 3D game. So what inspired me to make this video was the recent two tutorials Griffpatch just posted on how to make a tutorial. And most of this code was from Coding with Chris's video. I'll link both of their channels in the description down below. They're also very good Scratch coders, and I've learned from them a bit. So yeah, go check them out. So first of all, we're gonna start on how you want your map to look. Like, how do you want your place to look? Like, maybe you're making a maze or something of some sort. So how do you want it to look? So let's delete these two costumes in the Scratch cat, and we'll rename this map. And we'll also name the sprite map. So now draw anything to your will, and I want the fill to be blank and the outline to be black. The outline should be pretty thick and it should be black in color. So I'm gonna make the outline 3 pixels thick, and the color should be black. And I'm gonna make a circle boundary first of all. And to make a perfect circle, hold down shift and then make it. Now it just makes a perfect circle instead of you making ovals. So I'll just make like this big, and that should be big enough. And now we're gonna let's make it a bit bigger. Just that. Yeah, let's make it a bit bigger. Oh yeah, hold down Alt to draw it around the center of the circle. So instead of going like that, like moving around, the center always stays in the middle. So now like scale it up a bit, and that should be pretty good. And now just add walls, boundaries, whatever you want. I'm just gonna add a wall here, maybe make that wall a bit shorter. And then like add a wall over here, going from here to here. Then we can add like a circles. Maybe even some squares. And we can add like a couple more walls between them. Like a 90-degree wall, maybe. I mean, an angled wall, not a 90-degree wall. And yeah, you can do anything you want. Maybe I might put a circle in here, or maybe an oval. And yeah, that's my map. It can be anything you like. Maybe you might even want to bump up the outline thickness a bit so that the collision is more better. If the outline's too thin, Scratch sometimes doesn't detect you touching it. So it's better to have a thicker outline. Maybe not too thick. And just to tell you, later in this video we're gonna put this map as a mini map on the side of the screen so that the player can see where they are. You might not want this if you're making a maze game, and I'll show you how to hide that. But if you're not making a maze game, it's perfectly fine. So now we're gonna make a player to roam around this map. So you can just make a new sprite. Oh, this is not named map. Wait, did this get unnamed? I don't know how. We'll save it. And I'll paint a new sprite and call it player. And I'll also call it here player. And it doesn't need to be something very complex. It just needs to be a simple box of any color. I'll just do purple. And the size I used was a 7x7. So just, it's about 4 pixels in the scene. That's 8x8. So like maybe a bit smaller, and 7x7. So that's the size I used. That should be the optimal size you use too, but it's your choice. Now I'm gonna add a little arrow, like see where forward is. I'm gonna center the line a bit, like right there. And now I've learned this from Griffpatch. So to make a triangle, put a square, a simple square, and then you go in like the resize and design tool, and then you just select one of these and delete it, and then you have a triangle. Then you can just rotate it to be like that, and then put that back a bit, and there you go, you have an arrow. I might want to move the arrow a bit center like that, and there you have a arrow. And I'll just extend it a bit like that. Now we can see where the player is facing. Player might be too small for right now, so we'll just do like not 200, like 150, and that should be good for now. Now we're gonna start doing some code. So let's first do the movement script. So let's take a when green flag clicked inside the player and a forever loop. And first let's make the forward. So we're gonna take a if block, and if key W or up arrow pressed, it can be whatever you want. I'll use W, and W should be somewhere down here. W pressed, move whatever speed you want. So for mine, I use 1, but you can use any speed you want. And cause we're gonna use the speed for the backward scripts too, why not store it in a variable? So we'll just make a variable, or we'll rename this one, call it speed, and that should be good. And then we're just gonna do set speed to 1, and then we have a nice little place we can change the speed instead of going all over through the code. And we'll put the speed variable over here. Now if I press the W key, you can see my player moves forward by a very slow amount. You can change that to like 5 maybe, and that's super fast. And we might also want the player to start at whatever position we want. So I want the player to start over here. So place it wherever you want it to start and take a go-to block and put it at the top. So even if the player moves, when the player starts again, they'll always start over there. So I'm just gonna set this 3. It's like a middle speed. Should be pretty fast and nice. And now we're gonna also add the backwards script. So it's just the same thing, just backwards. And we're gonna do this. Now to make this -1, we're gonna do 0 minus speed. So if the speed's 3, 0 minus 3 is -3, which will give you the negative integer. 0 minus speed. And now if we try it, W makes us go forward, S makes us go backward. It's working. Now we'll implement looking left and right, and I'm gonna use the A and D keys for that. I'm just gonna duplicate that, put there, and throw the code out from there. And I'm gonna change this one to A and this one to D. And now we're gonna do a turn. So A is rotating to the left 7 degrees, and for D key it's the opposite, so turn right 7 degrees, so this way. And now if we try that out, and I can just turn around, look around, move forward, backward, and this is pretty good. But there is a problem. We can just pass through the wall like nothing. Like, just go through the wall, it's alright. But we don't want that to happen. We want to stop when we touch the wall. So to do that, we just have to move the player back the speed. So we'll move backward when it touches, move backwards when it touches the wall. So to do that, we'll just put a if. So if, this is for the W key first, so going forward, if touching map, just move 0 minus speed, so move backwards. So now if when I'm going forward and I touch the map, I stop. But when I move backward, that doesn't happen. And now when I move forward, I can't go forward anymore, even though I'm pressing it. But when I go backwards, I can still touch the wall. So now let's do the same for backwards. Just duplicate that, oops, and drag it into the S key. But instead of 0 minus speed, it's just going to be speed. And now we should have a nice collision system. It's pretty starter collision system, so not much, but yeah, it works. And now we can't just go through a wall, and yeah, and even I can't get out of the maze or whatever map you're making. So now let's start coding the actual 3D things. So we're going to make a new sprite and call it distance finder. So paint a new sprite and call it distance finder. And it's just going to be a very tiny dot, like 3 pixels in the center. So just click the plus button a bunch and a very tiny dot right there. That's all it's going to be. Maybe you might want to make it like 5, just in case your collision just doesn't work. And I'll just center that. Mine is 3 by 3 in size, even though this is 5 pixels. It doesn't make sense, but now I'm just going to zoom in, and it's a very tiny dot just in the center. Now, when we click the green flag, we don't want this to show, so we'll just do when green flag clicked, set ghost effect to 100, and this will help in the mini map so that we don't see it around. So we're gonna, in the player, back again, under each of these, the W, the S, the A, and the D, we're gonna broadcast a new event, and we're gonna call it find distance. And I just wanna broadcast it. Find distance, and I'm gonna duplicate this 1, 2, 3, 4, and then just put it in each one of these. Right there, and right there. So now let's go in the distance finder and click when I receive find distance. So when I receive find distance, we're gonna try to find the distance of how far the walls are from the player. So to do this in a snap instantly, we're gonna make a block. So we're gonna run it without screen refresh. So basically what that does is runs the block in 1 frame instead of normally, and we're just gonna name it receive distance. So receive the distance. And we're just gonna put that at the top. I left some space in the middle. Oh, where'd my block go? What? It's just gone. Where'd it go? What? Okay. I'll just... What? Where'd my block go? Okay. Can't search for it there. It's just what? Okay, let's make a new block. Can I also name this receive distance? Probably not. But let's just try. Oh, okay, yeah, I can. It's back. I don't know what happened there, it just disappeared. But now we're gonna add some code in this to find the distance. So to store the distances somewhere, we're gonna make a list, because we're gonna store a lot of distances. So we're just gonna call the distance list like distances, or maybe all distances, but it's your choice, whatever you want to call it. And now we're also going to make 2 new variables. One will be called distance, and one will be called angle. and you'll know what these variables are for in a bit. I'm also going to hide this list. And in the receive distance, first of all, we're going to delete all of distances. So delete all the distances, because we're trying to find the new distances when we turn or move forward, backward, or anything. So we're gonna delete all distances and set the distance to 0. So the starting distance is 0. And we're all gonna set the angle to -50. So what this basically does is, for example, this is the player and there's a ray going out from here. We don't want the player to get the field of view like this from here to there. We want to start at like behind, like on the other side, so going from there to there instead of going from there to there. We want it from there to there, so we get like a around view. So now we're gonna do repeat 100. So repeat 100 times, because we set it to -50 and we wanted to change the angle and find the distance here, and then it's going to go from -50 to 50. So it's going to give you a nice field of view looking around. So now we're gonna set distance to 0 here too, because every time we start we want the distance to be 0. And we're gonna do go to player. So go to the player. So I can't seem to find, oh, here. Go to player. So go to the player. And then we're gonna point in the direction. So oops, point in direction of the player plus the angle. So the angle is -50, so it's technically minus, and then it go here. So it's first gonna calculate the rays till there, and then it's gonna calculate there, and around, and -50 here. So we're gonna point in direction. So direction of player. It should be somewhere here. Yeah, this one, backdrop of stage to player, and then direction of player plus the angle. And that is going to be, it's a starting angle. So if I start it, it's always going to the player, and you can see it's underneath the player. Well, you actually can't see, but it's actually underneath the player. So yeah, nice. Or maybe it's above the player and just hidden here, but yeah. Now we're gonna repeat until, so repeat inside a repeat. So we want the ray to go forward until it's touching the map, or whatever view distance you want. So like how far you want a player to see. Either the distance is equal to that, or if it's touching the map, repeat it until it's touching the map, or the distance. So distance from the player equals 100 or something. I'm going to use 100 for this. So keep going forward until you're touching the map, or for example it's facing this way, or until you're 100 pixels away from the player, because we don't want the array to go too far and you can see walls from like 200 miles away or something. So yeah, now we're gonna what was I gonna do? Oh yeah, I forgot, sorry. So now we're gonna add a OR. For first, we're gonna check if it's touching the map, or distance is 0. I mean 100. So if any of those cases happen, stop going forward. So we're gonna go move 1 step. So the ray needs to go 1 step. Or it could be the resolution of the costume, so it's 3. So the maximum I should move it is 3, and 3 would be like for the best quality possible, because it's going to go fast and quickly, and you're gonna get your images nice and quick. So move 3 steps, and also change distance Actually, I should change this to 2, because the distance is going to change by the same number that it's moving forward. So if it's moving by 3, it's gonna never reach 100, and then it's going to go on forever, and that's going to be a problem. So it should be divisible by 100. So 2 is, and that should give us some nice quality. So right now you can't see the dot, but if I were to just set ghost effect to 0 right now, you can see the dot, and the dot doesn't seem to be moving. Oh, oops, I was supposed to put it when I receive find distance, receive distance, and now it should work. And it kinda, I don't know if it's working. No, it's not working. So maybe the collision is not working. That's why I might change the thickness of the map by like 10, and now let's try it. Or let's change this to 7 and change the distance finder, so the size of this little thing. Like, let's just hold Alt and bump that up a bit. And now we see, weird, it's still not working. I wonder why. So this shouldn't go through the wall. That should wait, code. Oh, that's the problem. It's supposed to be map here. And now, as you can see, if the dot touches the map, it's stopping. Okay, that was the problem. Sorry guys, I didn't realize that was the problem. So now, as you can see, it's very nice, and once it reaches a distance of 100, it stops. Now we want this to go all around. So for that to happen, we're gonna need it to change angle by 1. So now we're setting the direction to plus angle, so when we change the angle, the direction also changes. So set angle, change angle by 1. And also we're gonna add the distance that we just found to distances. So add the distance we found at the end after doing that to distances, and so that we can see everything going on, I'm gonna put it in the without that block, and as you can see, it's going on and around, and it's checking if it's touching the wall or not. And I'm pretty sure I can bump the speed up to like 4, because now the circle is bigger. And so now, as you can see, it's going around, checking if it's touching a wall or not, and you can see it in action right now. So that's why we put it in a block, first of all, that it just doesn't do that and we have to wait a long time for like check all the walls and then it finally renders out the 3D view. That's why we put it in a block. So just gonna take this back into there, that there, and that cycle should end in a bit. So it's almost -50 and there. And now if I move around, you can see it checking everything really quickly. Just zoom, 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 zoom. And if we were to show our distances, you can see it's added all the distances in all the directions, and you can see them change as I move around. So the last distance it calculated from my player said there was 20, which is right. Like if it's really far away, as you can see, it's 100. So yeah, as you can see, our distance sensing is working pretty well. So I'm just gonna clean up Blocks Plus. This is Griffpatch's extension. It's a really nice extension. First of all, it gives you this defined so you can look for blocks, and it gives you this Clean Up Blocks Plus, which is way better than the normal Scratch Clean Up Blocks. So yeah. Now let's implement the drawing or the showing or the rendering of the 3D view. So make a new sprite. Make a new sprite and call it code. So just the code of the rendering, and it's just empty. You don't need to show anything about it or anything. So now if we go in our code, we're gonna make the drawing code. So first of all, we're gonna make a new broadcast. So after all this is done, we're gonna broadcast a new message called draw. So draw the screen after you've got all the information about the distances. So we're gonna go in the code and we're gonna do make a new block, so the drawing is instant, called draw, and run without screen refresh. And we're also gonna put when I receive draw. I don't know how many times I just said draw in that single minute. So now we're gonna start drawing our screen. So to do that, we're gonna install or get the pen extension so that we can, instead of like drawing a bunch of sprites and making our code super slow, the pen tool will help, and we don't need to do any cloning and stuff, and it's going to be really helpful. So under the draw, we're gonna set pen color to whatever you want your maze color or map color to be. I want mine to be like a greenish color. Like make it like, actually I would actually recommend it to be like the full settings of saturation and brightness, because we're gonna dull out the faraway walls, and if it's like super dark already, it'll just become black. So you might want that, but I don't want that. So I'm just gonna set it to a very light green, and we're gonna set the pen size. So set the pen size. Oops. Set pen size. Wait, what? Oh, set pen size to, I recommend like putting it at like 6. 6 is where I got the best efficiency from, like the best quality possible. So that's what I recommend. And then we're gonna set the pen up so it shouldn't draw yet, and we're gonna erase the whole screen. So now we're gonna make a new counter for for loop. It's like a for loop in Python, but you don't have for loops in Scratch. So we're gonna need to make a new variable called counter. So we want to loop through the list. So to do that, it's just gonna be like for every object in the list, do this. So instead of that, we have to like add a little bit, just a very tiny bit more code to like make a for loop. That's what I was meant to say. So now we're gonna first of all get a repeat 100. So repeat for each single line. Repeat 100. And first of all, we're gonna set the y to negative 5,000 divided by item counter of all distances. So, oops, I didn't make the counter variable. So item counter of distances or all distances. So set y to negative 1,500 to item counter of the distances. So basically what this defines is the bottom of our wall, and then it's just going to go up and up and up and up and make one of the lines for a wall. So this divide will make the lines taller or shorter depending on how far away the line is. So right now it should do nothing. Yeah, right now the draw does nothing because the pen is still up and everything of our code is still working, and nice. So oops, I forgot to set the ghost effect here back to 100 because we don't want to see distance finder in our mini map if you want it or not. But now we're gonna do a if statement to see if the item counter of all distances, so this item is greater than, less than whatever your view distance you want to be. Like your field, how far you want to see. So for like slow computers, I recommend this value to be lower. Like the minimum I recommend is about like 50, and the maximum I recommend is like 101. Very precise, but like that's where I found my best working possible distances. But your code also gets buggy the lower you put the item counter. For some reason, like when I set it to 50, it just like makes me sometimes see through the walls, and I don't know why that happens, but it just makes it buggy. But for like good computers that like can handle nice far away lines and like high pen like lines and stuff, for that you can do a really far distance. So for mine I did 101. So now we're gonna start drawing the fun part. So we're gonna set the pen to down, and we're gonna set the pen brightness. So set the pen brightness to 3000 divided by item counter of all distances. So 3000 divided by item counter of all distances. So you can just duplicate it and put that there. And wait, what? I just clicked on that and said infinity, which is really weird. But yeah, so what this basically does is the further away the line is, so the further distance it is, it makes it darker. So it gives like more depth to your overall, and it makes it just look more natural instead of like everything being a flat color and you can't differentiate what far and close is very well. So after you've done that, we're gonna set the Y to the top, so the highest you want the wall to be. So you can actually set the bottom value like something super low, so that you want your wall to go all the way to the feet, and you can set your top value, you can set your top value to like something really high, so that you want the walls to go really high. But the values I recommend is -1500 and 1500. So it's gonna go from there and make a wall to the top. And that is the basic, and that is like almost pretty much it. We have to just add 2 more blocks, and which is and as you can see the line's working, but there's only one line right now, because I forgot to do this. And there is, oh yeah, all the lines are just being placed in one place, and we don't want that to happen at all. So we're gonna change the X value. We're gonna make these walls go there, there, there. I want to see if I can get a dark wall. Maybe not right now, but so we want to change the X so that this single line spreads around and makes a nice, beautiful looking wall. So let's stop the code, and we're almost done, very close to done. And we're gonna do change X by 6 or whatever your pen size is. And to also improve performance, you can make the pen size more thicker, but that reduces your resolution, makes it less natural looking, and makes it very like thick lines, and just doesn't look good. So this needs to be the same as the pen size so that they move like that. And as you saw there, the line actually moved. I don't know how I did that. Maybe I can get that again, but the code is not done yet. So oh yeah, we also need to change the counter. So we gotta change the counter at the end. But now this is looking very nice. And also, before we change the X, we also gotta do pen up so that it doesn't draw like a bottom line there, which won't look good. But now this should be the final step, and that is just to change the counter by 1. Ready for this? And ooh, something went wrong. Why is the counter increasing infinitely? Oh, oops. You also gotta set the counter back to 1 at the start. That was the problem, one of them. But you can kind of see on the side it's working. Oh, why is it all mushed to the side? Oh, oops. I'm making so many mistakes. At the start of the drawing, you want it to go, the screen to go from here all the way to there. So you want to set this part to like -238, so it's 240 pixels. 240 pixels this way, 240 pixels this way, so it's 480 in total. So we wanted to start at -238 or 240, but 238 works best, and end all the way at +238. So we're gonna do a go to at the top, -238 and 0, so it's the center. Now if we try it, look at this. You're in a 3D world. This is exciting, isn't it? And you can just see where you are on the map. And this is a wall right there. And wow, we have a 3D world now. It's very empty, but it works. And as you can see, this is the square right here. And let's go to the oval. Oops. Let's go over here. This is the giant oval right here. But this looks very like flying in the air type. So to like fix that problem. Oops, I paused my recording by mistake. So to fix that problem, you just go in the backdrops and just make a rectangle. For the sky, you can do any color. So I'll do like blue, or this could be like the roof or something, but I want this to be the sky, like a blue sky, and it should just go till the center. And then you can just duplicate this, go right at the bottom there, and change its color to like a ground, like grass, but like this color. And now if we run that, it looks a lot more natural and better. And yeah, that's the whole 3D game, and that's it. So now the only final step is either to hide this or to make it a mini map up top in the corner. So to hide it, I'm gonna show that first. The hiding is the easier part. You just first we stop that, and you can just put a when green flag clicked and set ghost effect to 100. So set ghost effect so 100. And do the same in the player. And we're not hiding these because that stops the collision. So set ghost effect to 100. And now if we run that, it's all hidden and it's still working. And it's pretty nice. I'm actually pretty proud of this. And it works well. You can see like the faraway walls are darker than the closer ones. Like this one is lighter than the really far away wall there. And if the code doesn't touch a wall, it just makes a dark green line. But as you can see, the code touched the wall there. You can just see like the difference. But like, yeah. And you can just roam around your map you made, just going around, and yeah, that's it. But now if you want the mini map, for that you have to have like a couple more lines of code. So for that, first of all, we're gonna set the map size to 50 and the player size to 50. Actually, well, 77, whatever it allows me. And we're gonna place both of these in like the top right corner. So what I found best, the best coordinates I found were to put these and at the coordinates of 158x, 158x, and 105y. So it's like in the top corner. And as you can see, the player is hidden and it can see nothing. Let's actually unhide the player. Now let's see. And as you can see, the player's found the circle, but it's outside the circle. And it's just roaming around outside. And oops, let's hit the edge. The really far away lines define the edges. Like that over there, I can't go any more forward. Like, yeah. These lines is defined infinity. But as you can see, we're outside. But now, we're also going to set the player's go to the same value. So 158, 105. Actually, maybe it's going to be 11 pixels up yeah, 11 pixels from this. So 158 plus 11 would be 169, and the Y would be 105 plus 26, which is 131, I think. And that should put it in the same spot. And as you can see, you have a mini map in the side, and it looks beautiful. You might want to make the map smaller. You can just change the map size. Actually, you maybe can't make the map smaller because of the player. But yeah, this is the tutorial. Thanks for you guys for watching, and make your amazing games and stuff using this, and boat to your freedom. And oops, I found a bug here, and which is because the circle is going out of range right here. It's giving me like this wall over there, but I can't go there because it's like the infinity wall, like which goes on forever and you can't ever reach it. So to just fix that problem, just move the map down or make the map smaller. But I'll just move the map down, but like 90 pixels to like 90 pixels I meant. And now as you can see, the thing is fixed. And thanks for you guys for watching this tutorial on how to make a 3D game. Also check out Coding with Chris and Griffpatch's channel. And maybe my player is too fast. I might want to change my player speed. I'm just zooming around the map, so I can just change that real quick to 1. So because of the speed variable, we don't need to go everywhere around and look. But now as you can see, I'm much more controlled. And sometimes you can like get, like if you like get squashed between like two walls, you'll just see nothing, which makes like a very weird effect. But as you can see, everything is working. This right here is this circle right here. I can go around it, and you have a nice looking 3D game. And this is the end. See you in the next video. Bye guys.